All right, well, welcome back to Calculus, Math 105. Good to see everybody here again. And I guess welcome to those of you who have now added since the last time. I know some of you have been getting shifted over from the other section. They're trying to balance it out a little bit. So if you started with Larry and now you're here with me, welcome. It's not going to be that different. Calculus is calculus. It's just Larry and I approach it maybe a little bit differently. But where we are right now is we're still kind of in the middle of chapter 1, which is a review of pre-calculus. I just want to keep highlighting some of the more important things that you're going to want later. All right. And so a lot of this is review. And if there are things when I'm going over them, you go, oh my gosh, I don't remember that at all. You definitely want to go back and look at them, go find a pre-calculus book or something like that and kind of spend some time looking into those things again, or coming to my office hour and things like that so we can chat. So this might feel like we're going a little bit fast, and it should, because I'm basically doing a year of pre-calc in 2 days, right? But anyway, so last time we got to the point where we were in our library of functions, right? I call it the library. It's just all the functions you should kind of know about. So we talked about the constant function, which is really boring. Its graph is a horizontal line. You always get the same thing every time, no matter what you plug in. And then we talked about linear functions, and those are the good old y equals mx plus b. And the big thing there is with the slope, tells you what direction you're going. Specifically, if it's positive slope, it's going to go up to the right. Negative slope, it's going down to the right. So it's either an increasing or a decreasing function, depending on the slope. And then we ended with quadratics. So those are the ones whose graphs were parabolas. And we talked about some of the important things there, the vertex, the origin, or sorry, not the origin, the orientation, and the intercepts, right? So that was parabolas, quadratics. So we're going to keep going and just talk about some more functions. And the next one I want to talk about are polynomials. So let me go to the board here. So the question is, what do you remember about polynomials? All right, so polynomials, these are the guys that are basically, I'm going to make this really generic. All right, a sub n times x to the n plus a sub n minus 1 times x to the n minus 1 plus dot 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 plus a2x squared plus a1x plus a0. Now, when you saw polynomials before, you probably didn't see it quite this mathy. But I want to also start introducing you to some of the generalization that we do with calculus and in math, and this is the kind of thing you're going to see going forward. So you notice here that I've got really 3 letters, right? I've got A's, X's, and N's. Okay, well, the X's you're used to, those are our variable, right? Those are what we call the independent variable. So you're used to the X's. The A's, those are just our different coefficients. Now, you're kind of used to, like, think about when we did the quadratic, right? When we were looking at quadratic last time, we wrote it as ax squared plus bx plus c. So you're used to having the letters here as coefficients. Well, that's what I did right here with the A's. With all these little subscripts, those are all my different coefficients. I could have similarly done a times x to the n plus b times x to the minus 1 plus c times the next plus d times the next one and so on. But the reason that we in kind of the math world instead go to these subscripts is because of two things. One, we might run out of letters. We're really restricted with how many letters we have in our alphabet, right? We've only got 26. I've already used one of them for my x, right? So now I'm down to 25. Well, what if my polynomial has like 100 terms? You go, well, then maybe we go to the Greek alphabet. Well, sure, but you run out there. They've only got 24. Then you go, well, maybe do the Hebrew alphabet, or then we go to the Chinese characters. But eventually we'll run out, right? Well, this is just a mathy way of saying I've got a whole bunch of coefficients, and I'm just going to label them all A, and the little subscript, that number down here, just tells me which one it is. It's paired up with x raised to that same power. So notice here with the squared, we've got x squared, so this is a sub 2. For the one in here somewhere is an x to the 5th, so it would have a sub 5 times x to the 5th. So that's just how that plays out. We use these subscripts whenever we're talking about the same kind of thing, right? All these a's are coefficients, so they're all the same type of object. And we just use those subscripts to tell us which one is which. Okay, so that's why we keep using A. And then you'll also notice that like with this highest power, I just have n. And I do this to say, well, I don't necessarily know what degree polynomial I've got. If this is quadratic, n is 2. If it's cubic, n is 3. But what if I want a 37th degree polynomial? So I'd have x to the 37, my n would be 37. So the next one would be 36, 35, and so on. So this is the real mathy, generic way of representing any polynomial. All right, so you're going to see me do this a lot, and it's not just me. I mean, you'll see this in all the math classes you have from here on, where we really generalize, because this is mathematicians being lazy again, right? I don't want to write out lots of different things, so I just took care of every single polynomial you could ever create, ever think of in the history of the universe, right here, one time. That's the epitome of laziness, right? Anyway, so these are polynomials. Now, some important things about polynomials is it is just a sum of difference of terms, and those terms are different powers of x. There is a highest one, and so this one out here, we call this one the leading term. So it's the one with the highest degree, and we usually do write them from highest to lowest degree, but that's not always the case. Sometimes we switch it around. But this one's called our leading term, and that exponent is what we call the degree. So the degree of the polynomial is n. So a quadratic is degree 2. A cubic is degree 3. A line, a linear function, is a polynomial, but it's degree 1. A constant is degree 0. Okay, so those are special cases of polynomials, but this is what they look like in general. So really the most important thing about a polynomial is its degree. That actually tells us a lot. And so here are some things we know about polynomials based on the degree. Okay, so here's some facts. Let's talk about some of the other things we've talked about, domain and range and all that. So the domain for these is all real numbers. It doesn't matter what polynomial you got. It can be any kind of a degree. You can have any numbers there for your a's, but the domain is always all real numbers. Now, the range is a little bit more difficult because it depends on n. So the first is if n is odd, and the other case is if n is even. So whether it's an odd degree polynomial or an even degree polynomial. If it's odd, the range is also all real numbers. So you can get anything out if it's an odd degree polynomial. If it's an even degree, you're going to get one of two things. You're going to get either a interval that goes, let's say, d to infinity, or from minus infinity to d. So which one of those you get depends on the leading coefficient. Okay, but basically you're either going to get from some number and bigger out, or from some number and lower out. And this all depends on that a sub n. And this first one is when a sub n is positive, and the second one is a sub n is negative. So to help you with this, because I know that all of a sudden now there's a whole bunch of information, you're like, oh my God. Think about specific examples of either odd or even degree polynomials that you know. And the easiest are linear. Linear is an odd degree. And so think about linear. For the linear, we get everything that we could possibly get out. For even, think quadratic. Because we know quadratics pretty well. Their graphs are just polynomials. So again, remember the orientation. Remember happy parabolas and sad parabolas. And that was all determined by that leading coefficient. Was a positive or negative? Well, that's what this is, a sub n. And so if it's positive, it's happy. So it's going to go up on either side. And if it's negative, it's going to be sad. So it's going to go down. And there's going to be a biggest place. All right, so there's a little bit about domain and range. So let's talk about things like intercepts and other fun stuff. So in terms of intercepts, the y-intercept, it's actually nice. It's always 0, a naught. So whatever this last term is, this constant term is, that's the y-intercept. And you can probably see why. Why is that the case? How do you find a y-intercept in general?
You set x equal to 0.
Yeah, you let x equal 0. So look at all of these things. If you let x equal 0, all of those terms, except for the last one, are going to go away. And so if they all go away, then all we're left with is that last guy. All right, so nice and easy in terms of the y-intercept. Now the x-intercepts, super challenging. So here's what I can tell you. I can actually tell you how many you might have. Tell you exactly how many you have, unless I do some work on this. All right. But it turns out that there's a maximum number, and that's actually n. So whatever degree your polynomial is, the biggest number of x-intercepts you could have is that same degree. Now, you don't necessarily have that many. Remember parabolas? Parabolas are degree 2. So what this is saying is that the most you could have is 2. All right, well, we knew that. But it is possible to have fewer. You've seen parabolas that only have 1, right? And you can also get 0. But the maximum number is n. All right, so Leah, you're saying the white